Hi guys, good morning. Today is Monday and we're going to be looking at a new topic in mathematics. Our topic is cones. So we're going to be discussing cones as our topic for today. Okay, but before that, I want you to just look at something. I want you to look at something. So tell me, just think about this question and see if you can figure out the answer, and then you know towards the end of the class if you're right or not. So can you replace that question mark with a number? So can you tell us the number, or can you think of the number that actually replaces the question mark? So just think of the answer and we'll see whether you're right or not. Okay? Okay, so let's take a quick review of the features of a cone. So this is a cone. Of course, you have the height here, and there are other measurements of in this cone anyway. You also have this side as the slant heights, and we have the base, we have the radius here also, and diameter and all that. But before we move on to use those in calculations, let's just look at the features. So features of a cone. Now, a cone has one circular plane face. That's also called the base of the cone. Okay, it's a circular face there. Then a cone also has one curved face. That's the part that goes around it. The part that goes around is called the curved face. Then we also have what we call the apex. That's the highest point there. The highest point there is also called the apex. Okay, so those are just some of the cone is not such a big shape. So it's a three-dimensional shape of course, but it doesn't have so many features compared to some other 3D shapes. So let's move on. Now, I want you to see some real life examples of cones. I think you can think about some off the top of your head anyway, but let me just show you some. Now, you, you've heard about ice cream. I'm so certain of that. I'm so sure about that. You've heard about ice cream, right? So this is an ice cream cone without the ice cream, of course. So I think you should have seen this before. You have the cone where you put an ice cream, you put some ice cream on it, and then you lick the ice cream off, and then you see the cone underneath. Sometimes you can actually eat the cone. So that's an edible cone, yeah. So just think about that as a cone, okay? That's a cone. Then you might have also seen this construction cone. It's usually placed on highways when the road is under construction. They place these cones on the highway to prevent people from going in that direction. So I think you should have also seen this. The top part is the cone. The top part, the top part of this construction cone, the top part is cone shaped. Okay, you can see that also. So these are some real life examples of cones, and I think if we have some of these objects in real life, it is only logical that we should know how to calculate the volume of these objects or the area of these objects, and understand their features. It's important. Okay, so let's just get into that now. But before we get into the area, let's look at how what's the cone made up of. We've talked about the features. Now let's cut that cone and let's see what it's made up of. We call this the nets of the cone. When you cut that cone into, try to see how what is made up. That picture is the nets. It's called the net of the cone. So the net of the cone consists of just two parts actually. It consists of just two parts. You can see those two parts, okay? So the sector is the first part. The sector is the first part. It's also called the curved surface, the one on top. You can see the part on top of the net there. It's the sector. That's the curved surface. So that curved surface that goes around, when you cut that out, it is a sector. Okay, it is a sector. And then we have the second part, which is usually the base, and it's in the circular form, so it's called the circular base. Okay, it's a circular base. Okay, so those are the two parts of the two parts of the net of the cone. Now let's now talk about the curved surface area. Okay, that's the area of the curved surface now. So let's bring back our nets. we can see that the curved portion is a sector. We already said that the curved portion is a sector. Okay, so to get the curved surface area, you need to get the area of that sector. That's all. So if you want to get the curved surface area of the cone, you need to get the surface area of the sector. Okay, so the curved surface area, like we said, is the area of the sector, and that is simply pi r times L, where L is the slant height. Okay, L is the slant height, not the perpendicular height, the slant height. Okay, so the curved surface area is pi r times L. Okay, now that is simply pi r L. IRL. So this formula actually is derived by getting the area of the sector. By getting the area of the sector. So once you can get the area of the sector, that is the curved surface area of the cone. Okay, so let's move on. Let's move on. Now we're going to find the total surface area now. Let's try to get the total surface area. Of course, we're still using the same net, but if we're to find the total surface area in this case, we must find the area of the curved surface and the area of the circle. So the total surface area is the area of the curved surface plus the area of the circle. Now we've gotten the curved surface area previously. Now all we need to do is add the area of the circle now. So our answer should look something like this. Curved surface area is pi RL and the area of the circle is pi r squared. So whenever you're asked to get the total surface area of a cone, just think about the two parts of the net. And the two parts are the curved surface and the circular base. So the curved surface area is the area of the sector, and that's pi RL, and the area of the circle is pi r squared. So that's the total surface area. It's as easy as that, okay? So try to put this formula in your head and try to remember how the formula is also obtained, okay? It's important. So let's look at an example, and let's see how we can use this formula in a real example now. So a cone of base radius 5 cm has a height of 12 cm. Calculate its slant height and total surface area. Remember we talked about how slant height is not the same thing as the perpendicular height. Okay, so remember that difference. Okay, so let's look at the diagram. So the cone should look like this. We have the perpendicular height as h. Okay, we have the perpendicular height as h, and we have the radius. You can see the radius on the circular base. Of course, it's the radius of the circular base. And then we have the slant height as L. You can see that. So take note of these notations. They're very important. When you see slant height, you should try to use L as always. And then when you see, when you're talking about the perpendicular height, you should try to use H always. And then of course the radius is R. So let's list out all the parameters now. We have our R here as 5. We have H as 12 centimeters. Of course, when you're not giving pi, remember that pi is 22/7. And then we are to find L, which is the slant height, and the total surface area. Okay, so those are the things we're looking for, and we have all the parameters that we were also given. Now, but I want you to understand that in any cone, the height, the radius, and the slant height always form a right triangle. I think you can see the traced out portion here. You can see this portion that has been traced out here, the height, the radius, and the slant height. This portion always, for every cone, is always a right triangle. It's always a right triangle, okay? So let's bring out that right triangle with our own parameters now. So we should have something like this. Remember that our slant height is L, we do not know it. Our perpendicular height is 12, that's H is 12, so we can represent it as 12. Our radius is 5. So our right triangle is as shown in that diagram there in black. So this is our right triangle. Now remember that for any right triangle, if you're looking for one of the sides, you can use the Pythagorean theorem. Again, this is the Pythagorean theorem, which states that, you know, the square of the hypotenuse is equal to the sum of the square of the adjacent sides. So we should have something like this from Pythagoras theorem. We have L square equals 12 square plus 5 square. Okay, this is from Pythagorean theorem. So L square equals 144 plus 25. L square is 169, and L will be square root of 169, which is 13 centimeters. Okay, so I want you to take note of this. Now, there's a common mistake that people, if sometimes they might not tell you to calculate the slant height, they might just say find the total surface area. Now, there's a common mistake to just use the height, the normal height, as L. That would be very incorrect. So please take note that you should find L first, whether or not you are asked to do that. Okay, so our slant height L is 13 centimeters. Now let's move on and try to get the total surface area now. So remember, the formula for total surface area is pi RL plus pi R squared. Okay, so pi R can be factorized out of that expression to make it look easier. So we can just say pi R into L plus R. That's another way to write the formula. Okay, but you can also decide to use it as it is, although it will be easier if you do it this way. Now, so we have pi R into L plus R. So our pi is 22/7, our R is 5, so times 5, into L plus R, that is 13 plus 5. Okay, 13 plus 5. Now, by the time we simplify this, we should have 22/7 times 5 times 18. Now, this gives us a decimal, which is 282.9 centimeters square. Okay, so 282.9 centimeters square. Okay, so that's that for our total surface area. So take each question one step at a time. It's not difficult, but you need to take it one step at a time and be careful not to make mistakes. Okay, be careful not to make mistakes when you're solving. So that's that for finding the area of a cone. If you're asked to find the curved surface area, you know that all you need to do is do pi RL. Okay, so take note of that. Now, let's talk about volume now. Let's talk about volume now, the volume of a cone. We want to discuss the volume, how to find the volume of a cone. But before that, I want you to understand that a cone is a special type of pyramid. Now, you've heard about pyramids. A pyramid is a three-dimensional shape. Now, it usually has a base, and then that base can be square, a rectangle, and so on and so forth, a triangle or whatever. And that base leads up to a sharp point, which we refer to as the apex. Okay, so a cone is a special type of pyramid which has a circular base. Okay, so now generally for the volume of any pyramid, the volume of a pyramid is usually 1/3 times the base area times the height. That's 1/3 times the area of its base, which can be in any shape, times the height of that pyramid. Okay, so if we come down to a cone now, we know that the base is circular, and that gives us our formula. So the volume of a cone will be 1/3 times. Now, what's the area of the circular base? That's pi R squared. Okay, so the area of circular base is pi R squared, so the base area is pi R squared. Now, times the height, which is h. Now, not the slant height, times the perpendicular height, which is h. So we have 1/3 times pi R squared times h, and that gives us 1/3 pi R squared h. It's close, it's very similar to the formula for volume of a cylinder. It's just the 1/3 that is, the different thing there. Okay, so try to also understand how we arrived at this formula and try to put the formula in your head. Okay, so you can recall it when you need to use it. So let's talk about an example now. Let's see how to use this. Now, we have a cone of base radius 7 cm and it has a height of 12 cm, and we are to calculate its volume. What do we do? It's easy. All we need to do is write out our parameters first. Our R is 7 cm, H is 12 cm, and pi is 22/7. So we are to find the volume. So we have listed out all our parameters, and we are finding our volume now. So to find volume, the formula is, we've said that 1 over 3 pi r square h. So 1 over 3 pi r square h, and we can now go ahead and substitute all these parameters into that formula now. So our volume V should be 1 over 3 times 22 over 7 times 7 times 7 times 12, which is the height. So by times 7, 1 7 cancels out the 7, and then 3 and 12 gives us 4. So we should have 22 times 7 times 4. This is just, simple division, okay? So 22 times 7 times 4 would give us 616 cm cube, or 616 cubic centimeters, okay? So remember that the unit of area is square centimeters or square millimeters, depending on the unit of measurement, and then volume is cubic centimeters or centimeter cube, or it can be cubic meters depending on the measurement of length. So that's that for finding the volume of a cone. Like I said, it's very easy and it's very straightforward. Okay, so what you need to know, you need to learn the features, you need to understand how to get the area, curved surface area, total surface area, and you need to also understand how to get the volume. If you can learn all these things about a cone, if you see cones in day-to-day, your day-to-day activities, it will be easy for you to walk around them. Okay, so that's that for volume. Now let's take a quick recap of everything that we have just mentioned. Okay, so we have said that a cone has two faces, and there's one circular face and one curved surface. We've said that, and we've also discussed how we can find the area of the curved surface. We said the curved surface area is pi RL. Then we also talked about how we could find the total surface area, and we said the formula is pi r squared plus pi RL. Then we went on to talk about how to get the volume, and we said that is 1 over 3 pi r squared h. So it's a very simple one. It's a very simple one. Now it's your responsibility now to try to see how to apply these formulas to more complicated questions. To try, whenever you see a question, especially if it's a word problem on cones, try to break it down. Try to figure out what you have and what you do not have. Even if the diagram is not given, try to draw your diagram. That will also help you to, to figure out how to solve it appropriately. So that's that for our summary. Let's just talk about the riddle and see how many of us got it right. So we asked how many people could, replace this question mark with a number, and of course, it's a simple one. When you have 1, the number 1, all you need to do is 4 raised to power 1. When you have 2, all you need to do is 4 raised to power 2. When you have 3, 4 raised to power 3. So obviously, for 4, we'll do 4 raised to power 4, which will give us 256. So our answer is 256. So if you got 256 and you got it right, you can leave a comment in the comment section just to say that you got it right. Thumbs up to you. Well done. Well done, well done. Always try to have fun, get some riddles, some puzzles, and see what you can figure out. It's a lovely experience. So that's that for our riddle. I want us to just look at something that I want you to just do at home and try to, get the answers right. So if you can get the answers right, you can also leave them for me in the comment section so I can see if you're right or not. So what I need you to do for this cone is to get me the curved surface area, the total surface area, and the volume of the cone. Okay, all units are in centimeters. I'll give you a hint. The first thing you need to find is the radius. So that's your hint. So try to get the answers, and if you can leave them in the comments section. So you can also decide if you want to visit quizzes.com and play some games on cones. Okay, so that's that for today's class. Is a very short one, so I hope you had fun listening. I hope you can boldly say that you know everything there is to know about cones, or every basic thing there is to know about cones. Yeah. So remember to like the video, remember to share to your friends, leave your comments. I want to hear from you guys. And then remember to subscribe and tell your friends to subscribe for weekly updates. So have a lovely day and take care of yourselves. Bye.